now the true kickoff of this event, and it's my pleasure to introduce our first speaker today. Melanie Wise is really a legend in the mobile robot space. She's, of course, known for starting Fetch Robotics, which, of course, was acquired by Zebra Technologies. Since then, she's moved on to Agility Robotics, where she's the Chief Product Officer. And I'd be remiss if not mentioning that she's the recent recipient of the Engelberger Award, the highest award the robotics industry has to offer. And I believe she was the second youngest person to ever win it. A little fact that I think still gnaws at her just a little bit, that she wasn't the youngest. Please welcome Melanie Wise.
Thanks, Robert.
Thank you for coming. Appreciate it.
Awesome. I'm waiting for the slides. Or do I have to? Okay. All right. So today I'm going to really talk a little bit about the current state of humanoid robots. This is one of the robots that Agility makes, the Digit robot. But the thing that a lot of people are confused about right now is everyone thinks that humanoids are like 10 years out. They're actually happening right now. Right now, right now. Not like tomorrow, not a year from now. It's happening right now. And the reason I know that is because we're already under contract with customers, doing work every day. And I'm not saying this just to brag about what Agility's been able to do, but also to make it clear that this is happening across our industry. And as someone who spent a good decade working on mobile robots, it's kind of exciting for me to see that AMRs are becoming really great companions to the humanoid robot. As you can see here, Digit's unloading an AMR. But we also are able to do a lot of different workflows with the robot. So it's not like that's a one-trick pony. We got one customer working and magic happened. We're actually doing it in different types of applications with different types of customers. And we're also playing in the automotive space. Here's an example of some of the work that we're doing with some of our automotive customers in their facility, actually on production lines, not in the lab, but on a production line on a live floor. And so I want to reiterate that it's happening right now. It's not happening tomorrow or 5 years from now. It's happening today. But I think it's important to also recognize that there's a lot of hype. Like it's out of control. People are showing videos of robots doing backflips. That's definitely a little bit out. I'm not going to lie to you on that. Robots doing backflips is definitely a little bit on the hype curve. And I think, there's a lot of great videos out there of humanoid robots doing cool party tricks. I mean, we all know and love these videos. They get us excited about the future, but they also paint a very futuristic view of where the technology is at. And I think although we've accomplished a lot, we don't see a ton of companies deploying. We see a lot of great YouTube videos, but we don't see the hard outcomes. And one of the things is when you go and you ask the community at large, when you ask people, okay, what is the barrier? Why aren't we getting out there? People will immediately say, we're missing the brain. We don't have AI. Who the heck knows what that is? And so without it, we can't do anything. Well, the fact of the matter is AI is not the barrier to scale that we all think it is. Like, all of the other robots that have been deployed for 50, 60 years haven't needed AI to get the job done. And we all know this. It's not like it's the big thing holding us back, like a parachute preventing our acceleration. And a lot of companies are already using it. Agility uses AI every day. AI has been rebranded about 30 different times in my career at least. But we already use it for getting the robots to stand up reliably from unknown configurations, for doing some of the bipedal movement learning, for doing some of the partial detection, things like that, tote detection. All of those things, every company is using some form of learning system. Now, whether it falls into the new, category of things that people care about, large language models, multimodal models. Maybe not, maybe it doesn't matter, because it's not the barrier to scale. And the other problem is that when you look at these learning systems, they need a lot of data, and they need specific data. So it's really hard to bootstrap yourself into a large language model or a large multimodal model without data, without getting into the field to get the data to get into the field. Like, it's a chicken and the egg problem. So if we were truly dependent on learning systems and large expert systems, we would have a problem. We would have this chicken and the egg problem. And I think that it is great to have that data, and it will help us create these expert systems. But it's, like I said, not the barrier. And if you go back to the community, they also have some other great opinions about what's holding us back as a community. Definitely sex appeal is one of the things holding us back. Everyone needs a hot robot. I'm not really sure why that was important, but you know, lots of people have opinions on what's going to make it easier. We need to build small humanoids. That'll solve the problem. We need to make it easier to buy. I mean, financing you can get. If you have a return on investment, trust me, financing will come. It's typically not the barrier to scale. And a lot of people believe it's dexterous hands. Unfortunately, the big thing about dexterous hands is we've been grabbing things for 60 years without dexterous hands. So I have a small disbelief that dexterous hands are the other thing holding us back in the world. And so when you look at all of this cool stuff that's happening, the real question is what's missing? What is that barrier to scale? What's the thing that's holding humanoids back? And I would say it's a two-part problem. It's a little A, little B. But I think the first one is meeting customer requirements. I think a lot of people who are technology-centric individuals, like myself, as someone who started a company as a technologist, you have this rude awakening one day. You wake up and you're like, oh, I have to do what the customers want for them to buy it. And I know you think it's silly, but as a technologist, you're like, if you build it, they will come. And then you turn around and you're like, they're not coming. They're not coming. What do I do? And so and everyone knows this, when you get into industry, when you get into talking with customers, what they care about is your success rate and your uptime. And really, a lot of people, when they look at what it takes to execute, it's really around a cycle time. And on average, a lot of the customers are looking for cycle times that are, in the 15 to 20 second range for an activity between unloading and conveyor. And these aren't hard to hit. It just takes engineering, which is not the same as AI. And so this is one of those things. This is a long tail problem. This is an engineering problem. This isn't an AI problem. And the other part that's missing, and I want everyone to take a really hard look at all of these videos, especially the Atlas one, because that will become very important in a minute, is we're missing the safety cage. And that Atlas video had padding around it. So that's not a cage, but it's reminiscent of one. But one of the things is that all of the companies out there today, when you look at the videos, we don't see the cages because we're trying to paint a vision of the future. We don't want you guys to get distracted and bogged down by cages. Like, that's not sexy, as we were talking about with sex appeal. It's not cool. No one wants to see a safety cage around their humanoid because it breaks the illusion or the idea that we can wander everywhere and solve these problems. But the fact of the matter is that there are 0 cooperatively safe humanoid robots on the market today. They just don't exist. And I challenge someone to find one. I don't know of one. And this is a big gap. And so it's not stopping us from getting into the market today. We're deploying in cages. I'll say that out loud. We have found use cases that don't need 100% roaming in a large facility for these applications. We do deploy in cages. But it definitely will limit the amount of scale we can get to. And I think it's important to realize that we're hand-waving at best one of the biggest obstacles of the industry. And I think the other problem is not enough companies take it seriously. I think you will hear from some companies today who are taking it seriously, and those are the leaders in our space. Everyone who's taking this challenge seriously is going to stick around, and we've been here before. When I started in the AMR industry a decade ago, there wasn't an AMR safety standard. We actually went off and wrote one. That standard actually applies to humanoid robots as well. It does have some challenges because it's a little silent on dynamically stable robots, and I'll talk a little bit about that. But one of the big things when you look back at that industry is safety was the ultimate decider of what companies were successful. And I believe that this will be true for humanoid robots as well. If you can't operate safely in a large-scale facility, you're going to have a hard time scaling, and you're going to have a hard time being productive and getting to a global footprint. And so when we look out at the humanoid industry, it's not AI that's the thing that's going to block us from scaling. It's our ability to do it safely in the environment. And so I just want to go over quickly some of the challenges and why we still have some work to do around the standards, but there's nothing that blocks us from a standards perspective of going into the market today, but there are some open-ended questions. For example, when an AMR loses power, it just kind of sits there. But when a humanoid robot loses power, it kind of looks like that. And that's not ideal, because the standard says that you can't move after a power loss situation. I think we failed the test. And a lot of humanoids have this problem. I'm talking about this openly. Like, most humanoids have this problem, and we're working on ways of solving these problems. The other problem is that for the last 50, 60 years, we have talked about presence detection or human detection in the scale and scope of planar LiDAR. So if we see an obstacle or a thing, don't go near it. But the problem is that when you get out into the real world and you can touch everything, and your job is to touch things, you have to be able to tell the difference between the thing you're touching and specifically a person. And here's an example of something that you see out there in the world today. So Digit is told to go grab this tote, but this individual is trying to grab that tote as well. And Digit needs to disambiguate between their hand, their fingers, their forearm, and the tote that they're grabbing. So it's a little bit more nuanced than the standard test piece of robotics, which is a 70-millimeter cylinder that only goes about this high. So if we use that as our basis for safety and detection and presence detection, we have a large gap. And so I want to highlight this as one of the unique challenges of our industry, is making sure that we actually can distinguish between the object we care about and people. I think the other thing is that when you look at AMRs, because they're dynamically stable, when they're carrying loads, it's no big deal. But if the robot is carrying a load and it needs to perform a protective stop, it actually should put the load down first and then go into its protective stop. And these are the types of things that we have to account for as part of usage of the robot. And then if we circle back to this problem with human hands. Everyone talks about dexterous hands, and the thing is that there's a lot of excitement about dexterous hands, but the fact of the matter is when you look in industry, people use tools to make their hands better. And also, many of our customers have been using robotic end effectors for a very long time. And when we go and talk to them, they actually want to take the standard end effectors on the market that they've been using to grab all the product they've been grabbing for the last 20 years and put those end effectors on Digit or on the humanoid that they're working with. And although everyone says, well, dexterous hands will eventually be able to do what those hands are doing, they might not actually. Because the thing is some customers have very specialized requirements, handling requirements, no marring, scuffing, ESD challenges. So it's important to recognize that there may be aspects of the product that you're handling that's actually constraining the hand that you put on the robot, not the fact that dexterous hands are cool. But I think it's important to recognize that deploying in a work cell is just the starting line, and that's where we're at. We're starting in a work cell, and we're just going to use a fence. But the thing is customers' sites are messy. They look like this. And you can't put a fence around this forever. And these are some of the customer sites that we're in today. And so if you look at the tasks that people are doing, it's really hard to put cages around all of these systems or solutions. They may have AGVs going through in and out of the environments that the robot has to operate in. And so it doesn't make sense to put cages around these environments. And so if we don't, solve for leaving the work cell, we're not going to be able to deliver the big value that everyone is hoping for. And we believe that humanoid adoption will plateau at some point because of this problem. And so I think that, when I look back at my history, when I look back at my history in this industry, I've had a personal commitment to solving this challenge. I was on the R1508 standard, was a large participant in it, and I've been a champion for safety with these robotic solutions. And I personally believe that this is the challenge that we have to solve, and I'm extremely committed to it. But the other thing is that Agility is committed as well. In the next 18 months to 24 months, we will release a cooperatively safe robot. And that's a big statement for me to make. It's not going to be an easy problem to solve, but we are going to be out of the cage in 18 to 24 months. And I challenge any other robotics company out there to try and do the same thing, because it's a hard problem, but we're committed to doing it. And why are we committed to doing it? Because we're working on a ton of other things for the robot to do. We want to go to new spaces. We want to solve new problems. We want to manipulate different things. And we want to expand the work that we're already doing today. And this is just a highlight of some of the scenarios that we're dealing with customers and out in the real world. And I think when you look at what this unlocks is right now we're in this space of where work cells are okay, but they're not a long-term solution. And once we get out of that, we can really get to all the other things that everyone's so excited about, the home and elder care, etc. But we first have to get out of the work cell, because you're not going to put a work cell in your grandma's house. You're just not. And so that's kind of table stakes when we look at the future of humanoid robotics. And cooperatively safe is the first step to getting there. So definitely feel free to follow our progress, but I think I have some time for questions. Thanks.
All right, who wants to kick us off here? I got a mic. Maddie's got a mic over there. I know we fed you up with some coffee, so I hope we've got. Bob's going to kick us off here.
Of course.
All right, Mr. Little, here you go.
Could you define what you mean by cooperatively?
Yeah. So on the spectrum of in a work cell to full collaborative safety, cooperative safety is there's a bystander task in the robot, and the person basically end up working on the same material but not touching it at the same time. Full collaborative safety is I'm touching simultaneous, like I'm having simultaneous motion and work with the human on the same work object. And so most AMRs are cooperatively safe technically. They're not collaboratively safe because typically they're not touching and working on the same work product at the same time.
All right, Melanie, back over here.
Yeah.
Hi, Natalie Brown from Analog Devices, Boston, Massachusetts. My question is about the standards for safety for humanoid robotics, and if the standards have not yet emerged, how can you be so confident to have a cooperatively safe robot?
Yeah.
Because we don't know what that is yet.
Yeah. So a couple of things. R1508 covers all ground-based mobile robots, so it is a standard that applies to the robot. It just has some silent parts. But also, safety frameworks are structured in a way such that they recognize that technology can move faster than the standards, which is definitively true. Like, it took us almost 7 years to write R1508. So when you look at the safety standard framework, standards break down into 3 categories, A, B, and C. A is a general standard. That's like the Machinery Directive 12100. That's ANSI B11. They kind of specify the high-level requirements for machinery or worker safety. Then you have B-type standards, which become a little bit more specific, and then C-type standards, which apply to very specific robots. If you don't have a C-type standard that exists, you can use an A-type standard as your normative standard for basically putting a robot in the market. Basically, C-type standards give you more information about how to handle very specific cases, but they don't limit your ability to put technology into the market.
Okay, we do have Maddie over there too. Just wave at her if you've got a question. But I got one right here,
Yeah.
Melanie.
Good morning. I'm curious how far along you are on the power loss problem.
Yeah. So right now, that's a very sensitive IP thing, and we are making good progress in that direction, but we are not talking about how we're solving that problem.
All right, who else? Again, you got...
we got a question.
Go there first, and I'll go back to you.
That's good.
Yeah, I got to ask the question of legs versus wheels.
Yeah, why legs versus wheels?
I think we should ask everyone that question today.
Yeah,
See how many different answers we get on that one.
As someone who worked on wheels for more than a decade, there are a lot of challenges at some point with your center of gravity and the amount of space you take up in an aisle. So most customers say, I have a 6-foot aisle, or even less, 5 feet. And you can only take up so much space because I got other stuff going on. I got people with carts, I got people walking by, and I can't have you taking up a lot of space. But the problem is when you get to a static footprint of the robot, you only have so much footprint that you can apply towards a CG that's offset. So if you need to reach up to like 6 feet in the air, about a meter out with a 50-pound load, you're definitely doing this with a mobile platform that isn't dynamically stable. Now you may say, well, why not wheels that are dynamically stable? And there is a good case for some of that, but then what you run into is some of the customers that we are working with need single or small steps that we have to overcome. And so the 2 driving factors that have driven us towards legs is basically overall footprint that we take up, and then the small steps that we have to take for like machine tending or other logistics operations. One of the things that you might have noticed with a lot of large-scale caged AMR systems is they build platforms for the pickers, and then all of the automation is moved up to that height, and there's like a set of stairs going up to it because they have to account for the AMR base. Well, when you try and drop a humanoid robot into that system, there's still 2 steps that the robot has to take. And so you still have these like challenges with the robot having to surmount a couple stairs or something like that in the facility. I'm not saying that the robot's going to go up a flight of stairs, but I am going to say that most likely our customers are going to want us to take 1 or 2 step-ups, and that in itself is a barrier for a mobile platform with wheels.
Right over here in the middle. Tell us who you are and where you're from.
Harry Pearson, Air Force Research. Harry Pearson for the Air Force Research Lab. For your cooperatively safe platform that you referred to, are you anticipating speed and power restrictions, and how much?
Yeah. So most likely we will solve this problem without using something like PFL. We will do distance and speed monitoring the way most systems do it, but it will have some very particular outcomes for speed and separation. But the problem is when you are lifting 23 kilograms, around 50 pounds, it's really hard to incorporate PFL because the amount of force you have to apply to lift up the object exceeds the safety limits for power and force limiting.
Hey, Melanie. Question regarding deployment. Do you see this more as for short-term and long-term, more of a capital purchase or a RAS moving forward? And how do you see like the advantages and disadvantages for each one?
Yeah.
You want to explain RAS?
Yeah. So there's predominantly two business models that are out there for this type of robot: CapEx plus SaaS, so capital equipment plus SaaS software, because these robots have highly complex software on them that do highly complex tasks, and you have to pay for the software that's being developed to accomplish those tasks. And then Robot as a Service, which is an all-in-one package that includes maintenance, service and support, software, and the robot itself. Right now, many of our customers are biasing towards RAS because the technology is moving so quickly. In the next 2 years, we're going to release 2 revisions of the robot. And so buying the robot as a CapEx robot is not really you're not strongly incentivized to do that because your technology becomes antiquated very quickly. So it's a lot better to be in a RAS-based model right now. I think long-term, there may be some advantages for doing capital equipment once the technology becomes more stable. But that really is something that customers need to think about as they purchase these systems. But I would recommend to customers considering humanoid robots to really look at RAS-based models because it guards against technology irrelevancy.
All right, right here.
Hi, Melanie. I'm Wendy Rusk. I'm in Charlotte, and we help support. We're a partner of Agility's. But I'm curious as to the workflows that Digit's doing today. Do you think that there would be many Digits doing many workflows, one Digit doing 2 workflows? How do you see that evolving?
Yeah, so right now, for example, with our customer at GXO, we actually do 2 workflows with the robot in one work cell. So we do an unloading activity, and then we do a destacking activity to put totes onto conveyor. And depending on the time of day and the workflow that's going on, the robot basically switches between those 2 activities. In the future, we see it being a mix of things, and it's kind of choose your own adventure. And it really comes down to whether you think you need a Digit dedicated to one workflow to get to the throughput or not. And basically, you calculate that based on cycle time. But we're building our system to be somewhat indifferent to it, basically building a system that supports an executor layer that allows us to deploy the resources against the task to meet the requirement. But yes, Rico has been extremely important for our success with our customers in the field.
We have a question over here.
Hi, I come from Zero Era. One of the reasons why humanoid robots clip down because when it's power off, it have no breaker inside each joint. So put a breaker inside each joint cost more volume, weight cost. It seems no advantage except more safety. So is that possible to make it force standard to put a breaker inside each joint?
Yeah, so the question is should we basically do what industrial robots do, which is cause braking whenever like a human is too close or whatever, we just freeze the robot. The problem is that even if we froze every joint in the robot, if we had forward momentum, we'd just be like a giant pendulum and throw ourselves in a very rigid state at a human, which is not great. So there are some consequences to choosing to break many of the joints in the robot, and that's not the path we're pursuing. We may do selective braking, and we may do damping of the different joints of the robot, but using a hard break of all of the joints of the robot, as far as we understand and the way the physics works out, is you basically become a rigid thing that falls on people, which is not ideal.
Melanie over here.
Yes.
Hi, Melanie. Carlos Richardson from Johnson Electric. You mentioned Digit's goal in the next 18 to 24 months to expand out of the safety cages, and I'm wondering if you or Agility have any beachhead markets or markets you expect Digit or Digit B2 or 3 to move into first, into those non-collaborative spaces?
Well, all of the logistics market is looking for cooperative safety. All of the manufacturing market is looking for cooperative safety. Basically, right now, the cage is a stopgap. All of our customers are actively pushing us to get out of the safety cage because of cost and other reasons. Basically, the ability to tackle different workflows and to not have to deal with the production friction that it causes also. Safety cages create a lot of production friction.
Hello, Denise Firestein here from GE Aerospace. I was curious if you could speak to Digit's ability to retask between different workflows.
Yeah. So if you look at most providers, and I'll speak a little bit to Agility, but if you look at most providers, almost everyone has like a cloud-based software that they're using to direct the workflows, or they have an on-premise software. They have some software at a high level that's directing the work. And we've implemented something like that. We call it Agility Arc. It basically allows you to schedule and allocate work to robots as they do their jobs in the field.
Yeah, this is Nick Damiano from ATI and Novanta. So building off the applications and markets question, if you look out 10 years, where do you see Digit? What are the top applications? What are the top markets?
Yeah. So I want to put out there that I'm not a fortune teller. And typically anything I say in about 2 years will be wrong. But if I were to guess, what you're going to see is growth similar to the AMR market. Like, everyone believes that humanoids are going to somehow be magically different, but they're going to most likely follow the trajectory of the AMR market. So we're going to see lots of logistics and manufacturing cases, steady, year over year, doubling, tripling, quadrupling of the CAGR, but it'll still be concentrated predominantly in industrial type applications, and then expanding out to industrial next applications like hospitality and other service applications. But we won't see like a giant leap to the home in a short amount of time. I don't believe we will.
Hey, Melanie. Milton Walker from Intel Corporation. So on the tail end of the port strikes, how do you talk about robot labor versus human labor, and do you see that as a difference from other automation or other AMRs?
No, I don't see a difference. If you actually look, so one thing that the last decade of my career has taught me is that when you look at what people are actually upset about when it comes to automation, it's about their fear of not being able to use the automation. Not their fear that their job is going away. It's that they won't be able to use the new technology. And if you look at it, once the technology is in and people become comfortable with it, they actually see a lot of job opportunity because they see, oh, it's actually not that hard to use. I can become a robot expert, and that's growth in my career. The real burden falls on companies to make sure that they have adequate training programs. And some of this is somewhat let's call it a political problem, because really it's around having the right tax incentive structures to re-educate the workforce. And those are not specific to the technology. And I think a lot of times we look at technology and we're like, what have you done for me lately? And it's like, well, I solved your problem. My responsibility is to solve the problem, not tell you how to retrain the people. Although it is becoming more and more of a hot topic in robotics, and we are becoming more focused on UI, UX, and usability because these are hot button topics that our users are really worried about. And if you look at how robots are used today, they're predominantly used through UI. They're not like people are touching the robots. So it's like, can you use a web browser to tell the robot what to do?
We're going to try to squeeze 3 more questions in
Okay.
here. There, and I got one over there. Sorry.
All right, I'll go first.
But we'll go there first.
Okay.
Hi.
So lightning round, Melanie.
Hi, Melanie. My name is Yoshi from Regal Rexnord Core Morgan. We're a motor manufacturer. And my question is, with new competitors entering the market, how has your organization responded or reacted to any new features or strategies that they're taking?
Yeah, our market is so young that it's really green space, so it's not like there's a ton of reaction that you have to have right now. I think we're pretty heads down on executing, because the thing is the thing that's going to like win the market in the next 2 years is execution. And no amount of cool videos is going to change the fact that you're out there executing with customers. Yes, it will get them in the door, but in my previous experience, they get in the door, they piss off the customer, and then about a year later, you're back talking to the customer. And that's what happens. And so typically in a startup at this stage of product and company, you just need to be heads down, focusing on executing and winning the customer's trust as much as possible.
Right here in the middle.
Mark Pogacek, Walter, up in Milwaukee. Question about justification and regarding as an example with the bin exchange, that obviously can be done through conveyor, other forms of existing automation. So what is the current perspective on just, I'll say, the humanoid in an overall, as opposed to, for example, just doing like a direct conveyor exchange or another? Yeah. How's that being justified today? And do you see that changing over the next couple of years as the product matures?
Yeah. Well, there's probably a reason they're doing it that way. I think when you look at it, a lot of AMRs are structured to, let's look at that example, the Spanx example. A lot of AMRs are structured to optimize for carrying the most load, not interfacing with other equipment, because the high value is throughput. So I want to move the most amount of material, and it's prohibitively expensive, and the flexibility of the operation is compromised by like running conveyor to every shelf. Would you agree? Yeah. Or they do have systems like that, but they can take a long time, they can be very costly, and they're built for a specific throughput, and maybe the system operation is going to change quite a bit. But because AMRs have been designed for throughput and high volume, they really typically aren't great for dealing with interfacing with other equipment. And so in that specific case, you could do what you're suggesting, but most likely your overall throughput would go down, even though you have a conveyor stub that you could kick totes off onto. Like, you eventually get to some operational frequency that the AMRs can't overcome. And so using a digit is very important in that case. But I think the other thing is if you look at a lot of e-commerce logistics operation, they're very peaky. And so trying to put static conveyor to like convey away your problems typically doesn't work, because you have like the large peaks that make the system very unstable when you use these kind of fixed conveyor systems. And so it's better to just have flexible labor in there to solve the problem. And digit is one of the ways to solve that flexible labor problem. Now, at the end of the day, the only thing that really matters is return on investment, is can you do it in a more cost-effective way than the other technology solutions. And so almost all automation is fighting against the state of the state. We're not really fighting, and anyone who's an automation provider in this room will tell you that. We're fighting against the status quo. We're not really fighting against other automation technologies.
Convey away. I'm gonna steal that one, I think. All right, last question. No pressure.
Simon Whitten, Ilgin Motion and Control. Quick question. You mentioned earlier that power and force limiting wasn't necessary, let's say, in certain work environments. Do you see the standards developing in the same way as robotics, with stop, speed and separation monitoring, and power and force limiting?
Yeah, so I didn't say it wasn't necessary. I said that given the current limits on power and force limiting, which is right now the current power and force limit for like an S1 injury, a minor injury, which is bruising, is 83 kilopascals, which is about 42 psi. That literally is like a feather touching you. It's such a light threshold that you picking up 50 pounds, like you already exceed that by the by. Right now, most of the standards are written from a speed and separation monitoring perspective, and that's because that's the state of the art right now, is there aren't a lot of safety-rated sensors out in the market currently that meet the requirements for doing more fancy things. And some of that is just because where we actually have a lot of blocking is we don't have good standards bodies for certifying advanced techniques, probabilistic techniques, or AI methodologies. There are standards or third-party V&V companies standing up like Certif AI, et cetera, to start verifying and validating. And there's also TS, technical specs that are, specifications that are going out there for how you even look at AI methodologies. But they're still very nascent and they're struggling. For example, the new TS on AI basically says, there's 3 buckets of AI. These 2 you can certify, which are basically standard methods. And then this third thing that is like what everyone wants to do, AI, we don't know. Like that's literally what the standard says. It says there's 3 buckets, and the third bucket that everyone wants to do, we don't really know. There's no way to certify it at this point in time. Good luck. And so we have a lot of problems with large-scale models and transparency and introspection that kind of no one has a great way of demonstrating the outcomes for without lots of data, lots of time, and large-scale simulation that is linked back to understood outcomes. And so these are some of the challenges that exist in the market today, but we're working through them.
Melanie Wise, everyone. Thank you.
Thank you.